Here I'll discuss mutually exclusive events and independent events related to probability. First of all, mutually exclusive events. For any two events A and B, we denote probability that both events A and B will occur as probability of A and B. It can also be denoted as probability of A intersection B. This is the sign of intersection. Okay. Now probability that either event A or event B will occur or both of them will occur as probability of A or B. It can also be denoted as probability A union B. This is the sign of union. Now formula for probability A union B is equal to probability of A plus probability of B minus probability of A intersection B. Okay. In a sample space, two events are mutually exclusive if they cannot occur at the same time. Let's investigate relationship between these following probabilities for two mutually exclusive events. Okay, let's understand an example. Okay, in rolling a die, if event A is getting 1, 3 or 5 and event B is getting 2 or 4. Now these two events A and B are mutually exclusive events. Okay, why they are mutually exclusive events? Because when the die shows 1, 3 or 5, it definitely cannot show 2 or 4. Okay, so these two events cannot occur at the same time. Now here the A intersection B equals to 5 because A and B do not have any outcome in common. Okay, do not have any outcome in common for two mutually exclusive events. Okay, then the probability of A intersection B will become 0 because there are no common outcomes in them. Okay, so if A and B are two mutually exclusive events, then probability of A or B is equal to probability of A plus probability of B, because probability of A intersection B is 0 here. Okay, now let's understand this diagram. Okay, suppose this is event A, this is event B. As it is clearly shown here that events A and B do not share any outcome in common. Okay, now suppose this is event A, so outside this event this will be A bar. Okay, complement of A. Now again this is event B, so outside this event this is B bar. Okay, now this region excluding A as well as B can be written as A bar intersection B bar. Okay, because the region excluding B is B bar. Okay, and region excluding A is A bar, and the region excluding these two circles is A bar intersection B bar. Okay, now let's look at an example. A club holds an election for the post of chairperson. The following probabilities for selection of two candidates are given. Okay, let event A such that Anjali will be elected. Okay, Anjali will be elected. And event B is Lakshmi will be elected. Okay, since there is only one chairperson, the events A and B are mutually exclusive events, because if Anjali is selected as chairperson, then Lakshmi cannot be, and if Lakshmi is selected as chairperson, then Anjali cannot be selected. Okay, the first question is probability of either Anjali or Lakshmi will be selected, so A or B. Now it is case of mutually exclusive events, so probability will be equal to probability of A plus probability of B. Here probability that Anjali will be elected is 0.36 and probability that Lakshmi will be elected is 0.47. So probability will be equal to 0.36 plus 0.47 equals to 0.83. Okay, now in second case it is asked that probability of neither of them being elected. So neither of them elected is equal to 1 minus probability of either of them being elected. So 1 minus probability of A or B. This is the probability that either of them be elected, and if I subtract this from 1, then I'll get the probability that neither of them will be elected. So 1 minus 0.83 equals to 0.17. Okay. Now, next is independent events. Two events A and B are said to be independent if occurrence or non-occurrence of any one event does not affect the probability of occurrence of the other event. Okay, so if A and B are two independent events, the probability of both events A and B occurring is the probability is the product of their individual probabilities. That is probability of A multiply by probability of B. Okay. Now let's look at an example. In tossing a fair coin twice, suppose a fair coin is tossed twice, tossing a fair coin twice. Okay. The event that first toss shows a head, and event B such that second toss shows a head. Okay. Event A such that first toss shows a head, then event B second toss shows a head. Okay. Now these two events A and B are independent events. Now why are they independent events? They are independent events because event A does not affect how likely event B will occur or vice versa. Now event B is getting a head on second toss. It does not depend whether there was head or tail on the first toss, because getting anyone head or tail is as equally likely as the other in second toss irrespective of the first toss. So A and B are independent events. Okay. Now example, the probability that A can solve a problem is 2 by 3 and that B can solve that same problem is 3 by 5. Okay, so you are given probability of A solving a problem is 2 by 3 and probability of B solving a problem is 3 by 5. Now these two are independent events because uh, A and B does not depend on each other. That is, it is independent of whether the other one will solve the problem or not. Okay. Now, first one is probability both of them will solve the problem. Okay. Both of them solve the problem. Okay. It is equal to probability of A multiply probability of B. That means simply you are asked probability of A and B. Okay, since they are independent events, so it will be equal to product of their respective probabilities. So 2 by 3 multiply 3 by 5. The answer is 2 by 5. Okay. Now the second case is at least one of A and B are able to solve the problem. Now now the question is asking probability of A or B. That means at least one of A and B are able to solve the problem. So it is asking probability of A or B. Okay. So or both of them can solve the problem. Okay, at least means either A or B or both of them are able to solve the problem. So it is equal to probability of A plus probability of B minus probability of A intersection B, a probability of A and B. This formula I have already discussed earlier. So 2 by 3 plus 3 by 5 minus probability of A and B is 2 by 5. Okay, so the answer will be 13 by 50. Okay, got it? Now next one is A and B are two independent events. The probability that both A and B occur is 1 by 6. Okay, now since they are independent events, then probability of A and B equals to probability of A multiply probability of B equals to 1 by 6. Now the probability that neither of them occurs, that means neither A occurs nor B occurs. Okay, again it will be equal to product of their respective probabilities, which is equal to 1 by 3. Now let probability of A equals to X and probability of B equals to Y. So probability of A complement is 1 minus x and probability of B complement is 1 minus y. Okay, so the equations here will be x into y equal to 1 by 6, first equation, and second equation will be 1 minus x multiply 1 minus y equals to 1 by 3. This is second equation. Okay, now on solving this equation, we get 1 minus x minus y plus xy equals to 1 by 3. Okay, so from here value of x plus y will be equal to 2 by 3 plus xy. Put the value of xy here, which is 1 by 6. Okay, so x plus y is equal to 5 by 6. This is equation number 3. Okay, now we have two equations and two variables. Okay, x plus y equal to 5 by 6, xy equal to 1 by 6. There are various methods to solve these two equations. One is you can form a quadratic equation whose roots are x and y, which will be equal to t square minus sum of roots into t plus product of roots. Okay, so equation will be t square minus 5 by 6t plus 1 by 6 equals to 0. On solving this equation, you can get the value of t as 1 by 3 or 1 by 2. Okay, now value of x can be either 1 by 3 or 1 by 2. Similarly, value of y can be either 1 by 3 or 1 by 2. The other method to solve this is from here the value of y equal to 1 by 6x. Put this value in equation number 3. So x plus 1 by 6x equal to 5 by 6. From here the quadratic equation formed will be 6x square minus 5x plus 1 equals to 0. On solving this equation we get the value of x as 1 by 2 or 1 by 3. So probability of occurrence of A equals to 1 by 2 or 1 by 3. Okay. Now next one is A speaks truth in 75% of the cases and B in 80% of the cases. Now in what percentage of cases are they likely to contradict each other in stating the same fact? Okay. Now event A is such that A speaks truth. Okay. A speaks truth. So event A bar will be that A does not speak truth. Okay. Obviously A does not speak truth. Then take event B as B speaks truth. So event B bar will be B does not speaks truth. Now probability of A is 75%, that is 75 by 100 and 3 by 4. Okay. Similarly, probability of B equals to 80 by 100 equals to 4 by 5. Now probability of A bar equals to 1 minus 3 by 4, that is 1 by 4. And probability of B bar is 1 minus 4 by 5, that is 1 by 5. Now event E such that A and B contradict each other. A and B contradict each other. Now I need to find the probability of this event E. Obviously, they will contradict each other when one of them will speak the truth and other does not. So, event E is equals to A speaking truth, B does not speak truth, plus B speaking truth and A does not speak truth. And these two events are mutually exclusive events here. Okay, are mutually exclusive events. Okay, when A speaks truth, he cannot tell a lie at the same time. Similarly, if B is not speaking the truth, then at the same time he can't speak truth in stating the same fact. So these two will be mutually exclusive events. Now probability of E equals to probability of A B bar plus probability of B A bar. Okay, which will be equal to probability of A multiply probability of B bar plus probability of B multiply probability of A bar equals to 3 by 4 multiply 1 by 5, okay, plus 4 by 5 multiply 1 by 4. Okay, why I have multiplied these individual probabilities? Because A and B are independent events. Speaking truth of any one does not depend on whether the other one is also speaking truth or not. Okay, so on solving this, the answer is 35 by 100. That is, in 35% of the cases, Okay, they are likely to contradict each other in stating the same fact. Okay, now from a well shuffled pack of 52 cards, 3 cards are drawn at random. Okay, find the probability of drawing an ace, a king, or a jack. Okay, now required probability is equal to, when first card is drawn, okay, then it should be ace. Okay, now there are 4 ace, so probability is 4 by 52. After one card is drawn, then the total number of cards remaining are 51. Okay, now since an ace is removed, okay, so total number of kings available are 4. Okay, now again in the next case, the total number of cards remaining are 50. Okay, because 2 cards are removed from it. Now since an ace and a king has been drawn, so a jack, for drawing a jack, 4 jacks are still available. Okay, now, okay, these are the probabilities of drawing an ace, a king, and a jack. Now, these three are independent events. That's why I have multiplied their individual probabilities. But you are not given the sequence, that is, on first attempt, whether ace is drawn, or king is drawn, or a jack is drawn. So, these three can occur in 3 factorial ways. Okay, these three can occur in total 6 ways, which is written as 3 factorial ways. So the answer will be, this is cancelled out by 13, by 2, 25. Okay, so 1 by 13, 4 by 51, 2 by 25, then multiply by 3 into 2 into 1. Okay, then 317 times. Okay, so the answer will be 16 divided by 5525. Okay,